Hello, everybody. Welcome. My name is Jake Brukhman from CoinFund. This is Crypto Talks. We're on YouTube today with Rettig of Crypto NYC and also an Ethereum developer working on Ewasm, and Beregszaszi, who's also working on Ewasm. Welcome, guys.
Hey, Jake. Thanks for having us.
Yeah, thanks for coming on. So this is cool. You know, I was hoping we could make this like a slightly technical talk, maybe not too technical, but you know, just really kind of dive into a little bit about what Ewasm is and how it relates to what's going on in the Ethereum development efforts and how you guys are working with that. And then maybe we can cover like some related issues as well. So before we do that, though, do you guys want to introduce yourself a little bit? Lane, do you want to give a quick like 30 seconds about yourself?
Sure. I'm a software developer. I feel relatively new to the Ethereum ecosystem. I've been doing core development related work for about a year now. The main thing I've been working on is Ewasm, which I guess we'll talk about a lot today. I also fired up this community here in New York called Crypto NYC, which also just celebrated its first year anniversary. So that's sort of a community of builders and designers and schemers and just like-minded people trying to make blockchain and Web3 more accessible to all the humans in the world. That's our mission.
Cool. What about you, Alex?
I'm a software developer as well. Started over 2 years ago, I think, on Ethereum, and I've been working on Solidity, the language design, as well as the compiler. And then roughly at the same time, also reached out to, I started work on both Solidity and Ethereum.js. And Ethereum.js is one of the client implementations most prominently used by all the client-side tools, including Remix and MetaMask. And that project evolved into Ewasm. So kind of been working on Ewasm and WebAssembly and Solidity at the same time for the last 2 years.
Excellent. Thank you, guys. So to frame the discussion, we should probably understand a little bit about what Ewasm is, and then we can jump into Ewasm. So Ewasm stands for WebAssembly. It's a virtual machine that can basically replace what the virtual machine that is currently used in browsers for JavaScript. Maybe you guys have a kind of a better description of it.
Alex, you want to take this one?
Well, you can go ahead if you want.
Sure. So the way I like to frame this is by invoking Java, which is sort of a language and a virtual machine that I think most people, certainly most technical people, are familiar with. So Java emerged in the 1990s, and there was this vision early on that Java would be a platform, a virtual machine that would run on any device, right? So I think even still today, I think that the branding around Java is like, runs on 10 billion devices or something like that. And so basically, in a nutshell, Ewasm actually delivers on that vision that Java wanted to deliver on and failed to for several reasons. And the reasons are fairly technical, but it's sort of a better designed virtual machine. It's more lightweight than Java. It's like Java, it's less opinionated than Java, right? So it kind of like integrates itself really, really well into the DOM, into the browser kind of document object model, which makes it like really, really good for writing and running applications at near native speed inside a web browser. And I guess it's also just the sort of end product of a very long lineage of technologies that have tried to make it possible to basically compile and run applications natively or near natively inside the web browser, right? So this goes back to technologies like ASM.js and Inscripton, which allowed you to produce something that was actually fully JavaScript compatible. And it's just a step further than that. It's just a re-engineering of the concept of a virtual machine. And I should also add, it's not just about web browsers. It also, like, none of the stuff that we're doing on Ewasm or Ethereum today runs inside a browser. Just like Node lets you have a JavaScript runtime outside the browser, you can also run applications compiled to Ewasm, just sort of on any platform.
In a standalone way. And so that's great. And then, just to frame anyone who might not be familiar with, virtual machines in general, like if you think about, back how programming languages were being developed over time, basically, you wanted to write a C++ program, you'd have to then go and compile it on your Windows machine, and then you have to compile it on your Mac, and then you have to compile it on your Linux machine. And so what a virtual machine does is says, why don't we create a layer of abstraction where you can just compile it once for the virtual machine, and because that virtual machine is supported across different hardware architectures, it'll just automatically run. And in many ways, Java, as you noted, Elaine, has done that. But the Java virtual machine is, it's very heavy and different advantages and disadvantages. And I think, like in the end, also, started to inherit some of the, hardware quirks of the hardware.
So right. So one of the points to make about Java is that there's a very tight coupling between the virtual machine and the language. So for example, there are like opcodes in the Java virtual machine, in the JVM, that allow you to do things like, I think, like introspecting Java objects, something like that. I'm not really a Java expert myself. And I think an important point of differentiation to emphasize is that Ewasm is a much more general purpose, lower level virtual machine, which actually looks a lot like an actual hardware instruction set.
Yeah, so that's a great point. And I think that, the basic like implication of that is that you have this, very low level virtual machine. And now you can write compilers across many, many different languages, not just Java, that compile to that virtual machine. Would that be like a correct understanding?
Yeah, absolutely.
Cool. Now we're all in blockchain, right? And so let's connect the dots here. Like, why does Ewasm, which is sort of like a general standard, right? Like, why does that matter to the blockchain space?
Well, Alex, you're one of the folks who kicked off this project in the first place. I feel like you should speak to this one.
I also wanted to add a couple of notes to the great explanation you did. Just a couple of interesting facts around just Java and JavaScript and then WebAssembly. So the fact is that Java wasn't the first one trying to do such a system. There were a couple of languages and systems beforehand, but Java was one of the first successful ones. And it was, as you mentioned, tightly coupled between the actual language and the VM. And the entire ecosystem was really just driven by a single entity. And it was so successful that at that point of time, browsers didn't have any kind of scripting. All of the browser companies tried to introduce their own version of scripting into the browsers. And then came around JavaScript, which took the language syntax kind of from Java because Java was really popular at the time. And basically, that's how JavaScript was born. It had nothing to do with Java, really, apart from trying to capitalize on the fact that it is similar, but it really isn't. And then all the browsers were dominated by JavaScript in the last last over a decade, maybe 2 decades. And out of that, there was another project which wasn't mentioned so far yet, called Emscripten, which is a project to compile any regular programming language to JavaScript. And even JavaScript has a subset called asm.js, which is a subset only, meaning that a couple of way instructions are written, can be detected by the VM in the browser and can be replaced with more optimized code. So asm.js is a way to write something which the browsers can optimize. And this tool called Emscripten can take C and C++ and a lot of other languages as an input, and can generate asm.js flavored JavaScript, which runs really fast in the browsers. And then the other big thing which happened with Web 2.0 was the fact of introducing video and audio into the browser. Of course, video was working even before that. There were proprietary plugins. Each of the platforms had their own versions of supporting video. But Web 2.0, and more specifically HTML4, set out the idea that video should be natively supported. And I think at this point, WebAssembly really ties into all of these streams because it tries to take the next step and make the browsers even more flexible and extensible than they were before. So WebAssembly really just started as a tiny virtual machine sitting next to the JavaScript virtual machine in the browser. It is controlled by the JavaScript piece of code running in the browser. So whatever the website has written JavaScript, that has the ability to control what kind of WebAssembly pieces of bytecode are loaded, how they are run, what kind of access they have to the browser, but the WebAssembly bytecode itself can be a black box to the JavaScript. I guess it also solves one of the other issues of how do people safeguard the intellectual property on websites. And what has been done so far mostly, if you really want to make something which is really flexible on the client side and put more of the work off the servers into the client, you write everything in JavaScript. But then the problem is, how do you protect that IP? And a lot of different obfuscation methods were introduced to JavaScript. But this is maybe another part which WebAssembly can eventually also solve. And one last remark regarding WebAssembly is it really started off as a tiny instruction set which can be highly optimized to translating into the local machine code. So it's designed to be executed efficiently and fast on the computer. However, it is designed to be extensible and flexible, and there are some plans and suggestions. And by the way, anybody can make a suggestion to the WebAssembly standards body, so to say, to introduce a new feature. And there are plans to introduce features which would introduce some properties which Java has. So maybe some of those properties will come into life in WebAssembly. And sorry for this long extra mile we have taken, but I think these probably were interesting facts to mention. And this was like the scene where we started to look into different virtual machines. So basically, this started over 2 years ago. And we kind of realized that the EVM, while it works and in some parts it's nicely designed, and it does have like a small surface area which can be easily understood by anyone trying to implement a EVM interpreter. So it's kind of small, it's kind of easy to fully cope with, but some of the design decisions in the EVM might not be the best, or they may not be designed to be executed really fast. It may have this legacy of using 256-bit as the smallest unit of data. So it is a stack machine, which means the bytecode can put values onto the stack, and then there are instructions which can take values off the stack and can put other values to the stack. And each of these stack items are 256-bit wide, which doesn't really reflect what the machines of today are doing. And all of the regular instructions a program would do is arithmetics, which means just making calculations, and there would be higher level instructions after that. And this fact of using 256-bit as the base size means that even if the program doesn't need to have 256-bit precision, the interpreter still has to do all this calculation, which very likely is futile. It's not really used.
So you're kind of saying, Alex, so in the Ethereum virtual machine, while it works well kind of in the Solidity context, if you were to try to go out and write kind of other programming languages, or even take a standard programming language and try to create a compiler for the EVM for it, you might run up against these kind of mismatches, or you're just using too much precision where you don't really need it, or is that kind of what you're saying? It's just not the best EVM to write languages for?
Well, I think this is my personal pet peeve. Why do we have this 256-bit stack item in the design? And I have a theory. I haven't been there when it was introduced, but it's also good that you mentioned Solidity, because there's another mention to be made there. So maybe I think the reason 256-bit is the stack size is that if you look back at Bitcoin script, which was the first, so to say, blockchain scripting, Bitcoin script, the main goal Bitcoin script is doing, it's a stack machine as well. There is a value on the stack, which is, I might be wrong now, but say it is the hash of the transaction, and you get the public key, and you can do hashing, and you can do some operations on them. But in the end, what happens is the calculation which happened in the script, the result of that has to match whatever was in the transaction. So that's what Bitcoin script is doing. And probably I messed it up entirely. And but the main goal, what it is doing is that. And from that, we can see that mostly it revolves around cryptographic functions, hashing and elliptic curve functions. And most of these, at least in the Bitcoin world, really work around 256-bit values. So I think this was one of the inspirations why to take 256-bit as a starting point. And that's also the reason why EVM, especially in the early days, had a lot of specific hashing functions and cryptographic functions in the virtual machine itself. Now, as of today, most of those have been moved off. Well, actually, as of Olympia, I might be messing it up, but the first public release only really had Ketchak 256, wrongly termed SHA-3 as the only high-level cryptographic or hashing function in the EVM. But it seems that for whatever reason, this basic design of 256-bit remained. And you mentioned that it works well for Solidity, but maybe it doesn't work well for other languages. And that's actually quite funny, because even in Solidity, in many cases, it would be beneficial to the user to actually use smaller value sizes. Because if they use smaller value sizes, there might be a guarantee on at the compile time to see if there's any kind of overflow happening. So say you have two 32-bit values, and there's a feature in the compiler which is experimental at the moment, but it would be able to detect overflows and certain other issues in the code at compile time. And that works well if you actually use the right size for the value you are going to deal with. But the fact is, the way the EVM works with these 256-bit values, what the Solidity compiler is doing, if you specify a smaller value, then it has to apply extra instructions after each operation to deal with it has to mask off the higher bits of the value. So it has to discard, say, if you have the 32-bit value and the stack size is actually 256-bit, it has to have instructions which removes or zeroes out all the top bits to do this each of the operations. As a result, people are not this because all of these extra instructions are reflected in higher gas costs. So even though there are these security properties people could use, people don't really use them because one driving factor they have is the gas cost. And that's actually not a thing the developer would notice, but it's rather the main issue a user would notice, that they have to pay too much. Or, in the worst case, the actual transaction, the operation you want to do, won't even fit into the block size. Or it would be just too big already to be picked up by the miners. So I think that kind of shows why the 256-bit might be a bad idea. I'm not sure if the point came across.
Yeah. So thank you for diving with us deep into that notion. So okay. So now we kind of understand some of the issues, right? Lane, do you want to take us through now that we understand Ewasm more or less and kind of the motivation for it? What is Ewasm specifically?
So I feel like we need to get this on T-shirts at some point. Ewasm is Wasm, just like plasma cache is plasma or whatever. And what I mean by that is that valid Ewasm bytecode is just Wasm bytecode. We've made a very small number of changes. There's basically two things we do to Wasm. The first is we need it to be completely deterministic. And so we need to remove sources of non-determinism in Ewasm. And so the main one here is floating point numbers, because the treatment of nans, not a number, is not deterministic. It's not fully specified in the Ewasm specification. So we turn off floating points, which turns out not to be a problem for Ethereum because we're always using integers, and the smallest unit of Ether is way. So we always do math on integers. And the second thing we do is, in order for a Ewasm smart contract to interact with Ethereum, right? So this could mean reading and writing from storage. It could mean returning a value from a smart contract call. It could mean reading context like the current block number or difficulty, something like that. We make available a set of functions. They're called EEI methods, Ethereum Environment Interface Methods. There's something on the order of about 30 of them as imports, as Ewasm imports. So if you write a smart contract in Ewasm, then you have access to importing these functions from the quote-unquote Ethereum namespace. So basically, that's what makes Ewasm Ewasm. Alex, did I miss anything?
Just be careful when you say that we didn't change anything, but then you said we did change.
Not change, just restrict. And I should also add, we add metering as well. And there's the Sentinel, which
okay.
makes sure that, yeah.
So Ewasm is sort of like the general specification. That might include floating point, et cetera, et cetera. When you go to Ethereum and you want to design this virtual machine on top of Ethereum, well, you don't need floating points. In fact, floating points are bad because they introduce determinism. And you need to let your programming languages to access kind of the context information. Like in Solidity, we're familiar with like, we have a reference in the programming language to the current block.
Yeah.
And you need to make that available. My understanding is through the virtual machine. Is that right?
Yeah. So it's a subset of the Ewasm spec plus imports. Plus, I guess we add metering, which obviously is important for Ethereum. That's how I would define Ewasm. Alex, did I miss anything? Did we miss anything?
Well, I think that this may sound kind of scary that, okay, we have this base Ewasm spec and then we have all of these things on top. But actually, if you look at it from the user's perspective or the developer's perspective, there's practically no real change to the developer if they use any kind of Ewasm toolchain already available to their language. Many languages have a Ewasm toolchain already, but not all of the languages have, well, different languages have different levels of integration with Ewasm. Some have way better integration. Some others have just very basic integration. And developers can use any of these tools without any changes at all if they want to write Ewasm compatible bytecode. Well, one thing to mention regarding this floating point, they may need to instruct a compiler not to use floating points. But that's the only thing.
My example question, like if I'm writing a Go program and then I have floating point arithmetic in it, and then I try to compile it with a Go compiler for Ewasm, what's going to happen?
In C compilers, for example, there is an option to specify a mode of operation called soft float, which means software floating point, which makes the compiler to include code to do floating point calculation over integers in the output, which is going to be a much bigger output and not going to be so performant on CPUs which do have a floating point. But this feature is used extensively in embedded systems where CPUs may not have floating point. So if the Go compiler has a similar feature, which I would guess it doesn't, but if it would have such a feature, then you would be covered. But you can always change your code not to use floating point, I assume, even in Go.
And I guess just to complete the thought, if you were to compile, let's say, a Go program with floating points to Ewasm and then attempt to deploy it to the Ethereum network, via the Ewasm tooling, we have a smart contract called a Sentinel contract that basically does two things. The first thing is it checks for things like the use of floating points. So in this particular case, that the create call would fail or the transaction would fail, and then it adds the metering as well. Yeah,
that makes sense. So is Ewasm, or the Ethereum version of Ewasm, is that meant to work side by side with the EVM, on top of the EVM, or is it going to be like replacing EVM eventually altogether?
I think that is a great question, and one of the biggest questions yet to be entirely answered. It is, of course, one of the questions we do get. Historically, the design has been influenced to work side by side with EVM. So it was designed to be introduced on the mainnet through a hard fork, where it would, after the hard fork, Ewasm compatible contracts could be deployed, but any EVM bytecode previously deployed would still be operational, or even after the hard fork, EVM bytecode would still be possible to be deployed. And this design also sparked another project we haven't mentioned called EVM to Ewasm, which is quite an interesting project. And basically what it tried to do is implement a EVM. Well, it's a compiler from EVM to Ewasm, so you would be able to have a purely Ewasm-based client, yet be able to run EVM bytecode. So that's how it historically started, and that's still what we are trying to achieve on the upcoming testnet we're working on. But meanwhile, in the last couple of months, there has been a way more closer interaction between our team and the Ethereum Foundation's research team, which includes all the people working on sharding and Casper. And probably everybody has heard about this new name called Jasper, which happened in the last couple of months when these separate teams decided to merge the efforts and not try to introduce Casper and sharding separately, rather try to introduce it at the same time. And roughly around that time, we came into close interaction with them, and the team working on sharding expressed a desire to perhaps use Ewasm as the execution engine on sharding. So that's another potential way to introduce Ewasm to Ethereum.
So the fact that you do have a degree of immutability in the contracts that have been deployed, right? So very first contracts that were deployed were deployed EVM bytecode. Does that mean essentially that we'll never get rid of EVM forever? Like either it will just always be in the system as kind of a for legacy support, or it will be implemented as a Ewasm underneath, right? Like, but we really are never able to like fully sunset EVM because we have contracts that are already deployed in EVM.
There's a couple schools of thought here. As Alex sort of suggested a moment ago, this is also kind of an open question at the moment, and the roadmap has evolved rapidly. One school of thought, so this is very tied into the sharding and Jasper roadmap, which Alex was describing, right? So one school of thought here is that once sharding works and comes online, right, each shard is a new universe. It's like a clean slate. And you could think of shards theoretically as being Ewasm native, such that all contracts ever deployed to that shard will always be Ewasm contracts, and there will never be any EVM contracts in those shards. And in this view of the world, the current Ethereum mainnet just becomes another shard. It becomes an EVM shard, and it's a little unclear what happens after that. But the thought is that over time, that EVM shard, that original shard 0, let's call it, kind of fades away in importance, and more transaction volume moves to newer shards. And there's various reasons that might happen. There might be new features brought into the new shards via Ewasm, new precompiles. There might be a fee market that it emerges, and maybe it's cheaper to transact on the Ewasm shards. So that's one view of the world. And in that view of the world, EVM sort of dies slowly, right? There's another view of the world where EVM will be around for quite some time for exactly the reasons you're describing, and we want maybe full cross-compatibility between the two. And client teams building new Ethereum clients today, like the Nimbus client that the status team is building, just to pick on one, should absolutely invest in EVM support. And in fact, we should continue to evolve EVM in parallel to Ewasm. So there's an initiative by a gentleman named Greg Colvin to actually upgrade EVM to this version called EVM 1.5 with a small number of changes. So those are sort of these two sort of competing views of the world right now.
Gotcha. So let's imagine, thank you for that, Lane. Let's imagine that your guys, the project is integrated into Ethereum. We now have Ewasm support. What are sort of the real world implications of this? How does this change programming on Ethereum and so forth?
Actually, one last note, which Lane mentioned briefly, is that if you have side-by-side, even on the same chain, so not talking about shards, just on the same chain, if you have side-by-side EVM and Ewasm, the goal would be that probably Ewasm in most of the use cases would result in lower gas costs. But that may not be the case. There might be highly optimized use cases where the EVM would be better cost-wise. And maybe the user would want to have different reasons to choose one or the other. So that's also a possibility. And an interesting fact to mention in that part is we have a kind of like a side project or a goal to make the system a bit more flexible than it is currently. And Lane has mentioned the Sentinel contract, which is our gatekeeper to the Ewasm world. So whenever a new contract is deployed, it has to pass through the Sentinel contract. And by pass through, I mean it is sent to the Sentinel contract, and the Sentinel contract does its thing and returns a modified version of that contract. or says that this contract is invalid, it cannot be used on a Ewasm chain. And this Sentinel contract, as you can imagine, does quite a few things. And it would be nice if this could be upgradable, on-chain upgradable, as opposed to upgradable through a hard fork. So we have this tiny side project called Sentinel Governance, where we reached out to different teams working on governance in Ethereum. And actually, it's quite funny that most of the code we have written in EVM, in Solidity for this, and only the actual Sentinel contract is the one not written not compiled to EVM. So even this right now works on a combined chain, which needs to have EVM and Ewasm at the same time. And sorry, I took another detour again, but I think this was kind of funny and touching into the same questions. Can
I just add one thing, Alex? So this is one answer to your question, Jake, which is there are interesting implications in an Ewasm world for governance. And I always like drawing parallels kind of beyond, the Ethereum world. This is actually what Alex is describing here, where we have this on-chain, it's a smart contract, but another way to think about it is sort of like a piece of runtime, right? So sort of in some way a piece of the protocol. This is exactly what the Polkadot team is doing. And they're using Wasm. They have their own version of Wasm called Pwasm, P standing for parity, which allows them to put a lot of the blockchain runtime on-chain and allow it to be modified and upgraded. So they have this interesting form of on-chain governance, and Wasm enables that as well. So theoretically, we can do similar things in an Ethereum world. And I think that there are this is actually one of the most interesting questions, right? This question you asked about what does an Ewasm-enabled future look like? If you actually go out longer term, I don't know how much time you want to take on this topic, but there's some like super exciting possible futures that it enables.
Yeah, let's mention it. But just before you get into stuff, just to summarize, right? You might be able to get some cost benefits on Wasm just because you're creating kind of more efficient bytecode. We heard that. You might have like a governance aspect. I think one thing we're probably missing is the fact that if you're running Wasm and there are many compilers for Wasm, you kind of open up to a much broader market of developers who can now participate in smart contract programming, right? And so to that, my follow-up question on that side would be like, how many compilers does Wasm have on it today? What kind of programming languages can we use on it?
It's a surprisingly long list. I'm going to get this wrong, but there's someone who compiled an open source list of these. I think it's called Awesome Wasm Languages. So this is a GitHub repository. So if you Google that phrase, hopefully you'll find it. And it's surprisingly long. I mean, it's on the order of like 40 languages or something. And they have varying degrees of Wasm support, as Alex said before. There's a small number that have pretty mature, pretty solid Wasm support, and also that are natural fits for Wasm, and others that are very nascent in their support. But it's important to point out that Wasm is missing some very important features right now. So for example, there's no garbage collection yet. There's no threads. So languages like Python, or Java that depend heavily upon garbage collection, currently the support is very limited.
I do see, I just pulled up your list and I put it in the chat box here, but
cool.
I do see Go, and Go is a garbage collected language as far as I know.
So is that hatched? Do you see that little chick icon next to it? Like, how hatched is it?
Oh, okay, I see. Gotcha. Yeah.
So maybe very nascent support. And just one other thought, like, I think this is a really important point to make. We've focused on a lot of the technical nice things we get with Wasm and with Ewasm, but the language support thing is huge. For me, it's less about compilers and more about languages and developer experience. I have a personal goal of getting 1 million or millions of developers building Ethereum smart contracts in the next year or so, which is a stretch, but I think it's possible. And my personal belief about how we get there is not through Solidity and Viper. All due respect to Solidity and Viper, they're important projects. They're domain-specific languages. They will continue to have great applications for a long time. But I think that there's a category of developer and a category of application where it would make more sense for us to give Web 2 developers and mobile developers a tool chain and a set of languages that they're familiar with already. Mm-hmm. And so that's why I'm personally working very hard on assembly script, which looks and feels a lot like JavaScript. So you use existing JavaScript tools you're comfortable with, like NPM, for example, to develop smart contracts.
Awesome, that's great. So now let's jump into what you mentioned before, Lane, which is like, what does the really like long-term future look like with Ewasm?
Well, actually, if you allow, one remark regarding the languages. Basically, one of the key points we were pushing historically was that language support would be wider. But I think this has multiple faces to it. It's not such a single thing that, okay, there are going to be multiple languages. And as you mentioned, different languages may have different level of support to Ewasm. And this, in many cases, doesn't even reflect that the current state of the compiler, in many cases, they would have like a limitation in the language itself to fully support WebAssembly to its fullest extent. So even though they have like a basic support right now, in a compiler, they might have more mature support in the future, yet they will not be able to fully exploit everything Ewasm offers. And regarding the GC, a garbage collected language, what this means is, as an example, it is possible to take a Python code and use the, I think it's called Cython compiler to turn it into a C code. And what that does actually, in many cases, it includes all these necessary pieces of code to do garbage collection, etc. So it pulls in a lot of things. And there are plans in WebAssembly to introduce GC kind of functionality as an extension to the WebAssembly bytecode to have two benefits: to save up on the bytecode size, because you don't need to include all of this code again and again. Second, to have it more optimized, because the VMs can really optimize it well. Well, that's the goal. But I think one important thing to mention in general is not just the ability to have more languages, but rather all the tooling coming with that. And by tooling here, I mean mostly security-related tooling and other kind of tooling developers should have access to. And like 2 years ago, regarding EVM and Solidity, that area was seriously lacking. And in the last 2 years, it really improved. But we kind of think and believe that the WebAssembly, because it has such a big ecosystem around it, it is much more likely that, around WebAssembly, all of these tools, mostly related to security, which is a really important part in a blockchain context, all of these tools would be available, and there would be many more tools competing, which may not be the case in EVM, because just the ecosystem is so much smaller. So I think that's one of the key points, one of the key benefits we actually get, as opposed to new languages. Because I'm kind of on the opposite side of the scale. I do like general purpose languages, and I think they have the role even in blockchain. I think one of the roles general purpose languages can play is providing low-level libraries to the blockchain. So for example, a hashing function could be highly effectively implemented, for example, Rust, put onto the blockchain to be utilized by other contracts. And these other contracts may be written in Rust, may be written in assembly script, may be written in C, but they may also be written in a domain-specific language, which really just exposes the bare minimum of features, maybe in a very opinionated way, but with the goal to make those features safe and secure. I do feel that all of these domain-specific languages do have a role, and they're going to keep continuing having a role, even in the Ewasm world. That's why in Solidity, we're trying to introduce Ewasm support in the compiler itself. And the project Lane mentioned, which I think lies in between a domain-specific language and a general-purpose language, is called AssemblyScript, which is kind of interesting because there was JavaScript, and then there's a typed version of JavaScript called TypeScript. And AssemblyScript is a subset of TypeScript, which also introduces WebAssembly features into it. And there's a compiler, a single compiler compiling this AssemblyScript language into Ewasm bytecode directly. Even though I have to mention that it uses a toolkit in the background to accomplish all of this. And that toolkit is part of the Scripton project we have mentioned earlier. And that toolkit is called Binarian, which is kind of like an extension for helping compilation to WebAssembly. And one last thing to mention in that regard is what I feel that, which is going to be like an interesting point in the future, is to have better tooling around WebAssembly. Because like Binarian is a highly experimental toolkit at the moment. But since there will be so many different use cases around WebAssembly, very likely they're going to emerge better toolkits. With those toolkits, we can build much better compilers and much better languages to WebAssembly. So I think that's kind of like the hope and vision for how WebAssembly and how we can benefit from that in the blockchain context. But I'm sure that we had a lot of different discussions across the team, and probably Lynn going to talk about that, what kind of other visions we could see in the future.
Just a final thought, adding on to what Alex said. I think for me, it's about maximizing developer choice. For me, Ethereum is still a young platform. We still don't know what it's capable of exactly or what it's best suited for. And so I think Ewasm is an important step forward in, it's a massive, massive, massive increase in optionality for developers. They can develop using different languages, different compilers. They can develop their own languages, their own DSLs, none of which are really possible in Ethereum 1.0 today. And so for me, it's just about maximizing the opportunity for experimentation, and that's how innovation happens. And we'll see what emerges. I mean, if it's the case that no one ever uses assembly script or Rust and everything's done in Solidity, that's fine. It's still an experiment that will have been worth running.
As you guys like work in the blockchain space on Ewasm, you mentioned, for example, the Polkadot is using it. Do you see Ewasm becoming a standard more and more across other blockchain network projects or other just sort of blockchain related or decentralization projects in general?
I think that's happening. I think that's underway. We have seen, in addition to Ethereum and Polkadot, EOS is using Ewasm, and other chains, I believe, as well, are using or talking about using it. We have other adjacent projects like TrueBit, which is based on Ewasm. I do think it's sort of fast emerging as a standard.
Cool. Dfinity would be another project that's working on Ewasm.
Definitely.
Cool. Is there any particular project that you guys have seen that's like farther along than everybody else, like that are almost there, or that have a deployment of Ewasm available?
Well, Parity does, right? So their sort of PWasm was, released and has been working for some months. So kudos to them for that. And as far as I can tell, the governance stuff on Polkadot is evolving quite quickly, and that seems to be working.
Excellent. To return to your vision, Lane, of like what is the really futuristic view of how this develops, and then I want to ask you guys a couple of questions about the team, and we're pretty much set here. But what do you think is the future here?
Yeah, I mean, I'll keep this brief. This is a huge topic, and in fact, we did a meetup in San Francisco 2 weeks ago where I had a chance to do a talk and share a bit of my vision. So I'll go ahead and post the link for that in the chat here in a sec, because I don't think I can do it justice in 60 seconds or whatever. But I guess at a high level, what excites me is that Ewasm is in many ways, if it works, and I think it is working, it's a new platform, not just for Ethereum, not just for web browsers, not just for the web, but for sort of all computing. And I know that sounds like a big statement, but like kind of, travel on this journey with me for a moment, right? If you buy that there's a future where, every computer, every laptop, every mainframe, every mobile phone, every tablet, as well as all the other places where web and JavaScript work today, right? So now we have refrigerators and toaster ovens and spaceships and cars, and like if you buy that, kind of we have this future where everything runs Ewasm, and Ewasm really does become a universal VM, which is definitely its vision. And on top of all of that, it's also the case that we have effectively native support for Ewasm on chain, on Ethereum and other blockchains. Well, now we have a future where we can go a long way towards blurring the distinction between running applications on chain or off chain, right? Today, there's a very, very sharp distinction between a adapt between a piece of smart contract code, Solidity, whatever it is that runs on the Ethereum blockchain and all the other things that run on my laptop, my web browser, my phone. But if we can blur that distinction, then I think it just opens enormous possibilities for really a new vision for a new compute stack where, consensus critical pieces of applications can run on chain, but the application itself can run natively and everything is Ewasm under the hood. That's the high level vision.
Well, very interesting. Okay, and finally, as a team, Ethereum is like a very interesting organization, right? Because it doesn't have sort of a central, corporation or point of control. And so can you just tell us a little bit about like what the Ewasm team looks like? Where do you guys work? How many people are working on your team? And how are you guys like funding this stuff?
Jake, just so you know, I just tried to post a link in the troll box and it won't let me post a URL. So maybe we can circle back and add that later, or you can uncensor it or something.
Cool. If you post it here in our group chat.
Right. Okay, cool. Alex, do you want to speak to this question?
Yeah, I think one thing to mention regarding the vision, there was one specific sentence saying everything runs on Ewasm, which probably is so to say like a dumbed down version of it. And of course, we don't really mean that everything just runs in a Ewasm VM and everything is interpreted, because that would give the idea that everything gonna be slow. What Ewasm here really means is the common meeting ground for all of these languages and VMs and execution. So whatever can be like compiled to Ewasm can be picked up by any of these tools, can be picked up by a blockchain, can be picked up by your browser, and it may be transformed before actually executing it. It may be compiled to your native machine. And this is kind of just like working as, in many cases, how mobile phones operate. Whenever you download an application on your mobile phone, it may be optimized. And that may include compiling parts of it to your native hardware. So the same is what we expect to happen with Ewasm in the future. It really seems to be a really good like baseline of instruction set to be used across all of these different systems. But it doesn't mean that we have to just interpret all of these instructions as they are in WebAssembly. It is just a medium of transferring all of this data and control. Regarding how the Ewasm team is structured, I can say that it kind of organically grew. So initially, it was Martin, BZ, and me on the Ethereum.js team. And we started experimenting with WebAssembly and this new prototype. So basically, it was just two of us. And then, because we were experimenting with Ewasm, and it was so exciting to experiment with that, we kind of didn't do a lot of work on Ethereum.js. And there was this other hard fork coming up called Byzantium back last year. And there was nobody to actually update Ethereum.js. And a lot of people don't really know what Ethereum.js is or whether it's important, but it's quite important because one of these really important tools called Remix uses it internally to execute contracts.
Mm-hmm.
And MetaMask.
And MetaMask as well in some cases, and there are lots of other users of it. But basically, we did realize that it cannot be sustained in the way it was. We needed to find people to work on it. And so we were very lucky to recruit and hire people to work on Ethereum.js. So we got Jared and Hugo and Holger joined the team, and they started to work on Ethereum.js. And then around last DevCon, we did a meeting across all of these different parties who were interested in Ewasm. And the main goal was to launch this testnet and work with the testnet. And practically a lot of people from the Ethereum.js team yet again moved on to this more exciting project, leaving the Ethereum.js team with a smaller number of members. And then parallel to that, we also, so the Ewasm project based on Ethereum.js, what it did, it was really browser focused. So it tried to build Ewasm entirely in the browser, which works really well, and the entire concept works really well in a light client setting, and that is still one of the goals to be achieved. But if we wanted to launch a testnet, then we definitely need regular client support. So because of that, one of the prototypes we had was a plugin into CPP Ethereum. And as a result, we did reach out to the CPP Ethereum developers. So Pavel from CPP Ethereum joined because of this reason. And from Ethereum.js, there was also Casey, who was the one orchestrating the hiring process of getting all these people on board to Ethereum.js. So obviously, Casey was really interested in Ewasm, and he's interested in a lot of things. But he just sticked around. And then also around that time, Lane joined the team. And later, through the grants program, there was a grantee called Paul, who was awarded a grant to write a WebAssembly implementation in Python. So we started to closely work with him, and he became a permanent member of the team. I may lost count, but I think we are. Oh, and one important person I kind of missed, who joined as a volunteer, and his name is Jake, and he started to work on this client implementation of the Ewasm engine. So he joined. Everybody joined the Ethereum.js effort, but he didn't join Ethereum.js. He joined this single Ewasm project. So all in all, today we are roughly 8 people. Oh God, I did miss one person. I missed Guillaume. So we did reach out then to, during the process of writing the client implementations, we reached a point that we wanted to have native support in Go Ethereum. And we were super lucky to recruit Guillaume, who was or is one of the masterminds behind. Damn, I forgot the name. What's the protocol called? So we have Whisper, yeah. So he's one of the main people behind Whisper, and he was working on the Whisper design in the Go Ethereum team. And somehow we made him excited about Ewasm. So he started to write a native. But there's a Go implementation of Ewasm. But he had to reach out to those people, and he joined their work, and then he successfully integrated that into Go Ethereum. So I think I didn't miss anyone now, and it's roughly 8 people, maybe 9, on the team. And as you see, that's a lot of different people, and I didn't really say where everybody's located because everybody's located remotely. I don't think there is, well, there's Lane and Jake in the same city. But outside of that, nobody is in the same city.
We have 3 people on the team with the same birthday, so we have more birthdays in common than we have cities in common.
So for anybody watching, if they are an engineer and they're kind of interested in the project, where do they go to learn about your project, your team, maybe even join the team if you're recruiting?
I would say, first of all, if you are coming to DevCon, if you're not coming to DevCon, come, because it's going to be a lot of fun. If you're coming to DevCon, look for us on day 2, which is the 3rd day. We're zero indexing here because we're engineers. We are doing a long breakout session. So come hang out with us there. We're going to do talks. You'll get an update about our testnet project. And then in general, the best place to find us is on Gitter. So Gitter is a chat client that's attached to GitHub. We spend a lot of time on GitHub and Gitter. So if you go to gitter.im/ewasm/lobby, that's a public channel where we're all in there all the time. And I would also say, if you look at the Ewasm repository, right, github.com/ewasm, there's a number of projects there, like in the design repository, where you can, it's an open source project. You can immediately come and start working on some of the issues.
Fantastic. Lane, Alex, thank you guys so much for an hour of your time to deep dive us into Ewasm. Really, really appreciate it. You guys are doing some very important work here, and I think like ultimately this kind of low-level infrastructure work is going to have big impacts, both within the blockchain ecosystem and beyond. So thank you so much for doing that. Thank you for joining us, and we'll see you next time at DevCon.
Thanks, Jake. Thanks for having us. Great to be here.
Awesome.
Thank you, Jake, for having us.
Bye.
Take care.
Bye-bye.
Bye-bye.